Okay, today on the Wilkin Way, we're going to do 4.3 and 4.8. It's right triangle trigonometry. And then 4.8 is also about word problems with right triangles. So we're not exactly on the unit circle in this one, but trigonometry is the science of angles, and so it makes sense that we're doing this. So one thing we want to be aware of is that we're going to round sides of triangles to tenths, we're going to round radian angles to thousandths, and we're going to round degree angles to the nearest whole number. So example one you could probably do without me explaining it to you. It says use the Pythagorean theorem to find the length of side C, then find the 6 trig functions of theta. So what we're looking for here is sine, cosine, and theta, and tangent. That was weird. And then you have to also find their reciprocals. So cosecant, secant, and cotangent. So because we're not imposed on an xy coordinate plane like we usually are when we're on the unit circle, it's totally fine and probably easier and probably the recommended way for you to go back to SOHCAHTOA. So you're just kind of expanding your definition of SOHCAHTOA when we say sine is y over r. It's not something completely different. If you look at an XY chart and impose a triangle on it, it matches up with SOHCAHTOA. But when we get into actually graphing sine and cosine, that's easier than SOHCAHTOA. So first we need to find our side C. So we might have a Pythagorean triplet here, so that just means that all 3 sides are nice even numbers. So let's see, we have 81 plus 144 equals c squared, so that's 225. So c is going to be plus or minus 15 when you square root 225, but we're going to ignore the negative case because the length of a triangle can't be negative. So that's what we get right there. So SOHCAHTOA, opposite over hypotenuse. Remember, there always has to be some angle that this is referencing. So opposite is going to be 9 over 15, which if you can reduce it, you need to reduce it. So that's 3 over 5. That's going to make cosecant really easy. We're just going to reciprocal it. So 5 over 3. This is adjacent over hypotenuse, which is going to be 12 because that's adjacent to the angle, and then 15, and remember your hypotenuse is always your longest side, so that's 4/5, and then over here that would be 5 over 4. And then our last one is tangent, which is opposite over adjacent, so that's 9 over 12, which is 3 over 4. And so then cotangent is the reciprocal of that, which is 4 over 3. Okay, so you'll have some homework problems like that. Before we move on to actually solving some of these that involve the calculator, I just want to remind you guys, or actually not remind you, but actually introduce you to how to undo a sine or a cotangent or whatever it is we need to do. So right here, you see that little degree symbol? That's going to tell us that our answer to this angle is going to be in degrees. So this is just an equation where we're expected to find the angle. This one right here, which is cotangent, because it doesn't have that little degree symbol, this is going to be radians. So in our calculator in today's lesson, we'll be going back and forth. So I told you guys yesterday that when you want to compute the cotangent of like 43 degrees, you don't do, well, first of all, you have to do 1 over the tangent of 43 degrees. You definitely do not say that this equals the tangent inverse of 43 degrees. Those are not equal. If you want to do this, you have to write it as the reciprocal. So the reason why is because mathematicians use that tangent inverse or any inverse trig function to undo what's in front. So we've talked about this a lot of reversibility in math. So if you divide then you can multiply to undo. If you square root, you can square to undo. If you exponentiate, you can take a logarithm to undo. Well, thankfully, mathematicians made this really simple for us. If we want to undo a sign, the inverse of sine is sine inverse. And what we do to one side, we do to the other. So then these cancel each other out, and I'm just left with theta. So then we go into our calculator and we hit mode, and we make sure we're in that degree mode. And then we're going to go second sine so that it says sine inverse. There we go, of 0.25. And that tells me it's 14.477. And for this lesson in your textbook, it asks you to round all the degree angles to the nearest whole number. So we're only going to go one beyond and look right there, and 4 is not going to round that 14 up to a 15, so this is just going to be 14 degrees. Okay, now this one right here, we're going to switch our calculator into radian mode. So we're going to hit mode and go back to radians. And then there is no cotangent inverse, so we just have to manipulate this a little bit. First, we're going to write it as 1 over the tangent because there is a tangent inverse button. And by the way, when you guys are writing these, you have to have the angle. So you either have a number or you have a variable that represents the angle. Sometimes students just write 1 divided by the tan, and that doesn't make sense mathematically. It's just like when we said you had to have something next to the logarithm, there had to be an argument. Otherwise, it wouldn't make sense. It's the same thing as this right here. So I want the tangent theta in the numerator, so I'm going to just multiply both sides by tangent theta. And then I'm going to have to divide this out to get it on the other side. So tangent theta is going to equal 1 over 4.375. So there we are right there. So now what I can do is tangent inverse both sides. So I'm just going to draw it in like this. Put parentheses around it so I know it goes to both. So then I have theta equals, and I already checked I was in radian mode, and second tangent to bring up tangent inverse 1 divided by 4.375, and that equals 0.225 because we are rounding that to the nearest thousandth. Alrighty. By the way, if you didn't already know this in math, instead of having to multiply both sides by tangent, you can do the reciprocal of both sides. So that would look like this. Just do tangent theta over 1 equals 1 over 4.375. And then you really don't need that 1 there. And if you look, that's exactly what we had here. So you can flip both fractions. That only works if you have one fraction bar on each side of the equal sign. Okay, moving along, example 3 says find the distance across the lake. So this is the distance that we're looking for right here. So because it's this trigonometry and this is a right triangle, we're just trying to figure out which trig ratio to use. Now, what mode should our calculator be in? There's our context clue. The given angle is in degrees, so our calculator should be in degrees for that one right there. So what you're going to want to do is label the side that you have. So according to this 24-degree angle, that would be adjacent and this would be opposite. So then what trig ratio would I need? That would be the tangent of 24 degrees. So we're actually putting an angle in here instead of a variable, equals x over 750. And then we're solving for x, so I'm going to multiply both sides by 750. So the distance across the lake can be calculated by multiplying 750 times the tangent of 24 degrees. So I have to go back through my calculator, switch it back to degrees, and then do 750 tangent 24 degrees. And our directions, because this is the side of a triangle and not one of the angles, are to round it to the nearest tenth. So that's going to be x equals 333.9, and we have yards as our measurement, so we're going to use our unit and put it there. Okay, example 4, I'm going to put a tricky on it just because I want you to come back and study what it means to be like angle of elevation and angle of depression, which isn't in this problem, but it's one that you might experience. So this right here says a flagpole. So here's my little picture. That is 14 meters tall, casts a shadow that is 10 meters long. Find the angle of elevation of the sun to the nearest degree. So here's that right triangle, here's what it is, and you're like, okay, well, seems like since the sun is up in the sky, this should be the angle that you're working with, but it's actually going to be this angle right here that you're looking for. And the reason why is because when they do the angle of elevation, they do it with the horizontal or like the horizon. So this is always the angle of elevation. And then there's actually something called the angle of depression as well, where you're going below the horizontal. So that's like if a plane is landing, kind of. It has to go lower. So angle of depression from its horizontal stance. So how the heck do we find this angle? Well, it's a triangle, so we can set up a trigonometric ratio. So because we're going to call this opposite and this hypotenuse in relation to the angle we're looking for, we're going to get the tangent of theta equals 14 over 10. And then I'm going to tangent inverse both sides. I'm going to reduce that just because I can. And these are going to cancel out. And so theta equals, now you're like, which one should I be in, degrees or radians? That's where if you read your problem, find the angle of elevation to the sun to the nearest degree. So there should be some sort of context clue. Checking my calculator to make sure I'm in that mode, and then doing tangent inverse of 7 divided by 5. If you did 14 divided by 10, you're going to get the same answer and it'll be fine. And we are rounding all degree angles to the nearest whole number, so that's going to be 54 degrees because we only need to look at the tenths place so that we see where to round that. Alrighty, moving on. Now we're talking about how to solve right triangles. So to completely solve a right triangle, you need to find all sides and all angles. So angles are capital letters and sides are lowercase letters. So I'll just put that uppercase are angles, lowercase are sides, and this triangle right here is just a general triangle. It is not drawn to scale. Alrighty, so I like to make my own triangles for each problem, even though I have this, because there's two problems. So this one right here, we're given A is 63 degrees. So I kind of drew a bad triangle already, so I'm going to just, it doesn't really matter, but I do like, your C has to be your hypotenuse, right? But I'm going to put my A down here, but that is a smaller angle. So again, I'm cautioning you, it's not drawn to scale. And then opposite side A, or angle A is side A. We know angle C is 90 degrees, and to find angle B, because the angles inside of a triangle add up to 180, I can subtract out the other two angles from 180 and I get 27 degrees. So that's angle B, it's right here. And then I just need to find side B, and if I find side B, then I can use Pythagorean theorem to find side C, or if I prefer, I could use another trig ratio. So here's where B is, and I'm also going to find C eventually, but because I want to find B, I'm given, and you can pick, I'm going to start with the 63 degree one. In relationship to 63 degrees, 8.4 is opposite, and this would be adjacent. So what is opposite over adjacent? That's going to be the tangent of 63 degrees equals 8.4 over b. I'm going to use my trick we just talked about. I'm going to make this 1 over the tangent of 63 degrees equals b over 8.4. Still need to isolate that b, so I'm going to multiply both sides by 8.4. And then again, plug it into your calculator. So it's going to look like this, 8.4 over the tangent of 63 degrees, because this is really 8.4 over 1. So when you plug that into your calculator, you're going to get that it is 4.3. And again, it's a side length, so we're rounding it to 4.3. And then if you wanted to find side C, you can definitely just use another trig ratio. You could use sine, or because that's opposite over hypotenuse, or you could use Pythagorean theorem, because I think that's much easier. That's what I'm going to do. 8.4 squared plus 4.3 squared equals c squared. And then when you do all your math, you get c is approximately plus or minus 9.4. And in the context of the problem, the 9.4 doesn't make sense, or the negative 9.4 doesn't make sense. So that's how you solve that one. B is a little bit different for part B. What you're going to do is you actually only have two sides. You don't have an angle. So how are you going to do that? It's the same thing over and over again. It's trig ratios. So this is angle C, angle A, angle B. I put 65 degrees for some weird reason, but it's really 65 feet. And then opposite, angle A is side A, so this is 30 feet. So I know side C is 90 degrees because this is a right triangle, and it tells you in the problem. And to find my missing B side, I can just do Pythagorean theorem real quick. So be careful, because you're not given the hypotenuse, or you are given the hypotenuse, you're not given one of the sides. So your setup is a little different. So then you're going to do subtract out. So we're going to get 30 squared, which is 900. So always follow order of operations, which says that you have to do parentheses and exponents first. Equals 4225. Subtract out the 900. B squared equals 3325. Square root, B equals plus or minus. And we have 57.7. You can always ask yourself if that makes sense. Well, this is the longest side, so as long as it's slightly less than that, it's good. And then when we go to check out our angles, we're going to expect the B angle to be larger since its side length is larger. So how do we go about finding that? Let's go ahead and find angle A first. It's right there. So I'm not actually going to label it theta. I'm just going to call it angle A. So with respect to angle A, this is opposite, and this is the hypotenuse. So opposite over hypotenuse, so Katoa, that would be the sine of angle A equals 30 over 65. You need to figure out what A is, so you need to undo the sine. So you're going to sine inverse both sides. And again, we are in degrees because the problem says to be in degrees. So we are going to do the sine inverse in our calculator of 30 divided by 65, and we get 27.4, so that's just going to be 27 degrees. What a quinky dink. And then that's going to make angle B 63 degrees, because these need to add up to 180, and we don't need to do the math for that because we just did it up above, but you can just subtract from 180. Alrighty, moving on to example 6. Here's another tricky that shows up on your test. So make sure you understand what's going on in this situation. Now you don't have to diagram it the same way I do, but You can if you want to. So first of all, a person is standing on the ground 100 feet from where a hot air balloon launches. So they're 100 feet away from where the balloon is going to launch. At one point, the angle of elevation from the person to the balloon is 31.7 degrees. So I'm going to just do some color coding here just to see if I can make your life easier. Who knows? So it went a certain distance and the angle of elevation is 31.7 degrees. So here's where the balloon was when the person first saw it at one point. And then it says 1 minute later, the angle is 76.2. So then this balloon climbs even higher in 1 minute. And now the angle of elevation. So remember that angle of elevation starts from the horizontal. So it's all the way from here to here. And that's going to be that blue piece all the way down though, right? Because look at that angle is opposite that side. So that's going to be 76.2. So it's not this tiny little angle. It's that whole blue length that's 76.2 degrees. How far did the balloon travel during the minute? So what we're really interested in is this right here. Now, you see this? This is not a right triangle right here. So we can't just subtract this angle from this angle and expect it to work out. But instead, what we can do is take a look at our two triangles that are right triangles. So we have this first one right here, and I can find the distance the balloon travels. This is my pink one. I'm going to call it x sub 1. I can find how far it travels there. So what would the ratio for that look like? It would be, I'll even write it in my pink pen, the tangent of 31.7 equals x sub 1 over the 100 feet. So that's the two sides of that smaller triangle. And then I'm going to do this bigger blue triangle, which is this whole entire length of that side of that bigger triangle. And that's going to be the tangent of 76.2 degrees equals x sub 2 over 100. And if I take the big blue one and subtract out the pink one, I'll get the yellow amount. So when I do the math for this, I'm going to multiply both sides by 100 and then plug it into my calculator. So 100 tangent 31.7 is 61.8. And then when I do the other one, I get that long distance is 407.1 feet. So if I want to know just that little distance, which I'll call x, and you can call them all different variables, it's going to be the 407.1 minus the 61.8, which gives me a total of 345.3 feet. Okay, now we're going to be talking about bearings, which is something that's new for you guys. So for bearings, the bearings are going to go like this. You're going to always do whether or not you're going to go north-south first. And then the second thing you're going to do is the angle to the north-south line, which is the y-axis. So this is different from our reference angles. Bearings help, they're a navigational system. So in like boats and planes and things like that, the north-south line is more prominent than the east-west line. So that's why we go to the y-axis and only the y-axis when we do bearings. So let me show you how these work. So the point from O, and O is the origin to the point D. First you report from this point to this point, you had to go south. And then you have to do the angle. So what is the angle from this point out here back to the north-south line? That's 25 degrees. And then from this point to this point right here, you are going east. So just a friendly reminder, never eat soggy waffles is your directional system there. Okay, to go from O to C, so here's O and here's C, you have to go south, and you can also see that you're going west, but your angle is this angle. So this is clearly not drawn to scale, because if this is a total of 90 degrees and that's 75, then this is 15 degrees. And just for practice, just to make sure you're getting it, you see what you would get if you would do O to B, and then O to A. I encourage you to go ahead and pause the video and do these. O is going to be north 40 degrees west, and O to A is north 70 degrees east. Okay, so that's the basics of bearings. Now we're going to do the application, which is the word problem. I am going to write tricky on this one. You need to study it. There's one on your test. And the more times you see it, the easier it gets. So whenever you make a change in direction, this is your helpful hint, draw a new north-south line, do like a new grid. Okay, so let's see what this is saying and try and give ourselves a picture. So a boat is leaving the entrance to a harbor, so we'll call this right here the harbor entrance. That's where it's going to be leaving from. And it travels on a bearing of north 42 degrees east. So it's going to go northeast. So it's going to go up to here, and this angle right here is 42 degrees. And it went 25 miles, so that's its distance. It's going to change directions. So when it changes directions, you're going to go ahead and draw a new north, south, east, west line. It's going to turn 90 degrees. That's not important. The reason, in terms of how you're drawing, is because that's just letting you know it's leaving at a right angle, so you have a right triangle. And then it travels on a bearing. It's going to go southeast, so it's going to come out here. And it's traveling on a bearing of south 48 degrees. So this angle right here is 48 degrees. And here is the boat right here right now. So how far is the boat from the harbor entrance? And we did know that this travels 18 miles. So it's really easy, even if you can't do the bearing parts because it's so new, that you just take the two distance values that you're given and do Pythagorean theorem, and you'll get that it's 30.8 miles away. The next part says, what is the bearing of the boat from the harbor? So you're starting from the harbor and you're going all the way to the boat. So if you look at that, you look like you're going what? Northeast? But what is your angle that goes in there? So here's the deal. You need the angle that corresponds to that. It's got to go all the way back to that north-south line right there. So it's that whole entire angle. And then what we know is we have 42 degrees of it. So if you look right there, there's the 42 degrees. But what we need to find is this angle in here, right in there. So because this was 90-degree turn, we have a right triangle, and this is the angle we want, so we have opposite over adjacent, so we just set up our trig ratio. It's going to be 18 over 25, and then we inverse tangent both sides, plug it into our calculator, and we get that little angle in yellow is 36 degrees. So this angle right here is 36 degrees, but I want the whole entire pink angle. So if I take the 42 degrees plus the 36 degrees. That gives me that entire angle back to the north-south line, which is 78 degrees. Okay? So example 9 is very similar. It's just talking about hiking instead of a boat. So I'm starting it right here because I know where this problem is going, but you leave the entrance to a system of hiking trails. So right here is your entrance. And hike 2.3 miles on a bearing of south, 31 degrees west. So this is 31 degrees. And you go 2.3 miles, and that's 31 degrees. Okay, then the trail turns 90 degrees. That's so that we can get our right triangle. So because we're turning, I'm drawing a new grid. And you hike 3.5 miles on a bearing of north, 59, because you have to come off your north-south line, west. So, and you're going 3.5 miles. And this angle right here was 59 degrees. And then the question is, how far away are you from the distance, from the entrance now? So it's important that you know it says from the entrance. So it's how far are you away? So you just do Pythagorean theorem again. 2.3 squared plus 3.5 squared equals the distance you are away squared. And that distance is 4.2 miles, which makes sense because it needs to be bigger than the other two. Now the next thing I need to know is what's your bearing. So you're going from this point to here, so you don't know if you're above or below that line because it's really close. The way you'll know is if this angle adds up to more than 90 degrees. If it doesn't add up to more than 90, then you from here to here you would be going southwest. So I need this entire angle. Once again, I have the little tiny piece of the angle, which is right there. That's 31 degrees. But I need the other piece of it, which is right here. So the way I'm going to get that is because I have the right triangle turn right here. It's going to be the tangent of, and you're going for this angle right here. So opposite is 3.5 and adjacent is 2.3. You still don't know yet which, you're obviously going west, so that's the one piece you do know. So let's find that little angle and see if it's more than 90 degrees, in which case we'll know if it's more than 90 degrees it would be swinging up here and we would be going north to get to our picture, and if it's less than 90 degrees then we'll be going south. So inverse tangent both sides, and I end up getting theta equals 57 degrees. So this yellow part is 57 degrees. So if I take my 57 degrees and add it to the angle that I already see in there, which is 31 degrees, I get a total angle of 88 degrees. So can I go from here to there and make it 88 degrees? Yes. So I actually am going south 88 degrees west. And that's it. Have a good day.